Another divide and conquer based sorting algorithm is a quicksort. Quicksort is known to be as fast as merge sort. It is better when you have an array of data, but merge sort is when you have a linked list data though. So this is the algorithm sketch. So in a public interface would be something like this quick sort function where you provide an array. Let's assume integer at this moment. You can make a template function for any data later though. So here is then array is provided and the size of the array is provided. Then this is just public function for quicksort. Then we are going to design a recursive version of the quicksort given an array and then the start index and an end index. So we call first with the entire array. So, and then quicksort recursive implementation is there. Before you apply actual sorting, doing shuffle the data is very important. Let me explain the reason why it is so in the later though, but this will affect the performance of quicksort algorithm. So this shuffle needs to be done. Then recursive implementation. Remember, we solve for the base case, the trivial size. If we have only one element in the array, that would be trivial size. So starting index and end index, if they are the same, then that's a trivial case. One element only, sorting is done. You don't have to do anything at all. And then go through partition. Now, unlike merge sort, you spend some time in carefully partitioning one array into two. That is a given array. We find the good some value called pivot, and if this is to be the one in the middle of the value range would be best, but there's no guarantee for that anyway. So find some value and then all the value, suppose this is k, then on the left side of the array just put all the value which is less than k. Right hand side put all the value which is greater than k. That is a partition. Once the partition is done, then recursive sorting. So from the beginning to less than the pivot. So here left side of the array just recursively sorted out, and the recursive design, smaller size solution is available, so call recursively. And then for the right hand side, do the array. Now starting index is after the pivot and then to the end. So sort it. So if you sort the right hand side and left hand side independently, then you don't have to merge. They are all sorted out automatically. So that's the idea of the quicksort. And the quicksort, like merge sort, the time complexity big O is n, log n is the time complexity. We'll show you how to prove that formally later.